Okay, so today we're going to start chapter 7, which is on quadrilaterals and other polygons. And today's lesson specifically is 7.1, which is on angles of polygons. So we're talking about, if I have a polygon here. Oops, let's fill it in with a different color. Okay, so if I have a polygon there, I'm talking about the interior angles, which are, the interior angles are the ones on the inside. And then I'm going to be talking about the exterior angles in a little bit here. And the exterior angles are when I extend one side of the polygon and measure an adjacent angle to one of the interior ones. Okay, so let's get started. We're going to start with interior angles. And to know this, we need to know what a diagonal is. The diagonal of a polygon is a segment that joins two non-consecutive vertices. So for instance, in this polygon I drew up above, the orange one there, a diagonal would be, again, two non-consecutive segments. So from this vertice to this vertice, it would be, there's a diagonal, or here's a diagonal. But I can't draw a diagonal from two that connects two consecutive vertices, because if I connect two consecutive vertices, then it's just like that, and that's not a diagonal that goes through the polygon. Okay, so go ahead and go to this GeoGebra link. It should be linked in Canvas for you. And you're going to explore this little exploration here and use the table in Notability, in your notes, to fill out the number of sides. So for instance, I will do the quadrilateral here real quick. So if I go to the quadrilateral, okay, let's load it real quick here. I can see that there's 4 sides on the quadrilateral. So I go to the table and I write a 4 in here on number of sides, the number of triangles created. So if I slide this slider, it says show the interior angles. You can see that there, it's checked. And if I slide the slider, okay, how many triangles were created? It looks like 2, right? I've got 2 triangles created inside that quadrilateral. So this is 2 triangles created, and the sum of the interior angles, that's something I have to figure out. So if I go back to this, the interior angles I can see here, I wish I could point for you, but I can't. The interior angles, if you look on that top triangle, there's a green, maroon, and pink angle. And if I add all those up together, it's 180 degrees. Cool, because inside that top triangle there, it's 180 degrees. On the bottom triangle, it's green, blue, and pink. That adds up to 180. So this triangle is also 180 degrees. So I add 180 plus 180 for a total of 360 degrees for the sum of the interior angles of a quadrilateral. Now you guys go ahead and pause this video, and I want you to fill out all of these. You can try to do the n-gon, but we can do that together. But go ahead and fill out all of those there. Pause the video. Okay, welcome back. So here's what we should have. Let me go ahead and undo a few of these things here so that you don't see it. You should have had these for the number of sides, the number of triangles created, 1 through 6 there, and then the sum of the interior angles, those values there. Now, let's see if we can find a connection between these two. Hopefully you already tried to find a connection, but if you didn't, we can look at, let's say, how did I go from number of sides to number of triangles? Well, notice I did 3 minus 2 to get 1, 4 minus 2 to get 2, 5 minus 2 is 3, 6 minus 2 is 4, 7 minus 2 is 5, and 8 minus 2 is 6. So I take, if this is my number of sides n, and an n-gon, then n minus 2 is the number of triangles I can create. Now, the sum of the interior angles, what did we do? We took the number of triangles and we multiplied it by 180 degrees. 2 times 180 is 360. 3 times 180 is 540. 4 times 180 is 720, and so on and so forth. So I take this, n minus 2, times 180. But be careful, if I got to take n minus 2 first, the number of triangles, I need that in parentheses. So we have this formula here. The sum of the measures of the interior angles of a convex n-gon. Convex means it just doesn't cave in on itself, right? It doesn't go into the interior. So the interior angle sum is 180 times n minus 2, where n is the number of sides, which is the same thing as the number of angles or vertices. So for example, find the sum of the interior angles of each. A convex decagon. A decagon has 10 sides. So I take 180 times 10 minus 2, which is 180 times 8, and that gives me 1,440 degrees. Convex 22gon now. That has 22 sides, so I do 180 times 22 minus 2, which is 180 times 20, and that gives us 3,600 degrees. This next one, I'm going to have to count the sides on. So I count 1, 2, 3, 4, 5, 6, 7, 8 sides. So n is 8. 180 times 8 minus 2 is 180 times 6, which is 1,080 degrees. All right, example 2. Classify the polygon by its number of sides if the sum of the interior angles of the polygon is given. So this time I know what the sum is. I have to solve for the number of sides using that same formula. So I set it up like this. I do 180 times n minus 2 is equal to that 2,160 degrees. So this is, oops, here we go. This is that formula for the sum of the interior angles. Since I know the sum of the interior angles, I set it equal to that known value. Then to solve, I'd start by distributing that 180 degrees, which gives me 180 times n minus 360 equals 2,160. Let's see, maybe add 360 on both sides. We get 180n equals 2,520. Divide by 180, and I get it's a 14-sided polygon, n equals 14. So we call that an n-gon. Or sorry, a 14-gon, because it said to classify it. So we do have to call it the 14-gon. Okay, now we have 4,500 degrees. So I do the same thing. 180 times n minus 2 is equal to that 4,500. Now we solve for n. Start by distributing the 180. When I distribute it, I get 180 times n minus 360 equals 4,500. Add 360 on both sides. So 180 n equals 4,860. Divide by 180 and we get n equals 27. Classify it, it is a 27-gon. All right, example 3 is going to involve a little bit of algebra. So we have to find the value of x. Well, notice all the angles that I'm given here are on the interior. So I have to find the sum of the interior angles, and all these should add up to equal that amount, and that allows me to solve for x. So I need to know how many sides we have. We have 1, 2, 3, 4, 5, 6, 7 sides. It's a heptagon. N equals 7. Find the sum of the interior angles. So 180 times 7 minus 2, which is equal to 900 degrees. Then I'm going to add each of these up, all these angles together, and set all of them added up together equal to 900. So first I go through the polygon and I figure out how many x's do I have variables. I have 1 x. So it's going to be, when I write it out, I'll show you in a sec here, but when I write it out, it'll be 1x plus, and then I'm going to write down what I get when I add up all of these values right here and set that equal to that 900 degrees. So I have x plus 806 when I add them up equals 900. Then I subtract 806 on both sides. That gives me x equals 94. Same thing on the next one. First, count all the sides. 1, 2, 3, 4, 5, 6. It's a hexagon, so n equals 6. The sum of the interior angles is 180 times 6 minus 2, which is 720. Now I have to add up all of those angles on the inside. So I start by adding the x's. 8x plus 5x plus 7x plus 6x is going to give us, let's see, 13, 19, 26x. And then I add on what I get when I add all of the just plain degree or numbers. So 110 minus 1 plus 36 plus 116 plus 19 minus 2. And that gives us 26x plus that number there, which is 278, equals 720. Subtract 278 on both sides, and we get 26x equals 442. Divide by 26, and we get x equals 17. All right, go ahead and pause the video, and you try these 3 problems here. Okay, here's what you should have. Number 1 is 5,400 degrees. 2 is an 11gon. It's also called a hendecagon, in case you were wondering. Number 3, this one was a little tricky. You had to notice that the 6th and 7th angles are congruent. So you add all these up, 1, 2, 3, 4, 5. So you add these up together. You have to add on 2 unknowns. So that's plus x plus another x, or plus 2x. Then you solve for x and you get 143.5 degrees. Okay, regular polygons, and angles, of course. A regular polygon is both equilateral, that means all sides are congruent, and equiangular, all angles are congruent. We have to find the measure of each interior angle of a regular octagon. So first of all, an octagon has 8 sides, right? So I find the sum of the interior angles of the octagon. That's 180 times 8 minus 2. That gives us 180 times 6, which is 1,080 degrees. So that means on this octagon, let's see if I can draw a quick octagon here. It's a regular octagon, so wish me luck. 1, 2, 3, 4, right? 1, 2, 3. Ooh, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Will it draw it for me? Close enough. So it's a regular octagon. Ooh, it doesn't look like one at all. These are all congruent, which means all these angles are congruent, right? Well, if I know that the sum of the interior angles is 1,080 degrees, and all those angles are the same, let's call it x, then that means I can just take 1,080 divided by 8x, because if I add up all these little angles, and they're all x, it's just 8x, equals 1,080. So you're just going to do 180 divided by 8, which is 135 degrees. Okay. B, each interior angle of a regular polygon is 120 degrees. Classify the polygon by its number of sides. This is like just the reverse, and this is a little tough to think about. Each interior angle, what did we do? That means if we know each interior angle is 120, then I know 120, I can write this off to the side for you. I know 120 times however many sides that guy has, we don't know, should be the same thing as the sum of the interior angles of all those, right? Of that insided polygon. So that sum of the interior angles is 180 times n, we don't know the number of sides, minus 2. That's just that formula. So that's what we're going to use here. 180 times n minus 2 equals 120 times n. Then I would probably, distribute that 180 to start here. And that gives us 180n minus 360 equals 120n. Subtract 180n on both sides to get the variables together. That gives us negative 360 equals negative 60n. Then divide by negative 60 on both sides, and we get n is equal to 6. We have to classify this. A 6-sided polygon is a hexagon. All right, pause the video, and why don't you try these two here? Okay, so here's number 1 for you with all the work, and number 2, the trickier one of the two probably. You should have had an 18gon for that one. So the answer on the first one was 140, second one 18gon. All right, let's talk about exterior angles. So if you thought some of the interior was tough, guess what? Exterior angles is like a piece of cake. You just have to remember one thing. The sum of the measures of the exterior angles, exterior, of a convex polygon is 360 degrees every time, no matter what. So if I go back to that GeoGebra thing right here, oh, here we go. And let's look at like any of these polygons, really. I'm gonna look at this one right here. 1, 2, 3, 5. So it's a pentagon. So I'm gonna look at this guy here, and I'm gonna show the exterior angles instead. Here we go. So those are all the exterior angles. If I slide this over, okay, they're all gonna move, boom, they make a circle. That's 360 degrees. Doesn't matter where I put any of these vertices, it's always gonna be 360 degrees. I can even go down here to a larger one. Let's say this is a 1, 2, 3, 4, 5, 6, 7, 8 octagon. Again, I'm gonna show the exterior angles. Slide the slider, all these angles are going to come together and make a circle, 360 degrees. So no matter what, the exterior angles of a polygon, or convex polygon, are always going to be 360 degrees. Kind of nice. So I just need to add up all the exterior angles here on the first example and set it equal to 360. So I have 3x total plus 156 degrees when I add 89 plus 67 equals 360. Subtract 156, I get 3x equals 204. X is equal to 68. Okay, on the next one, I'm going to add up all the x's. So 7x plus 5x plus 4x plus 4x plus 9x. And that gives us that 29x right here. Oops, here we go. 29x. Add up all the numbers. 4 plus 9 minus 6 plus 1. That gives us 12. Set it equal to 360 because we're on the exterior of this polygon. Subtract 12 on both sides. 29x equals 348. Divide by 29x equals 12. All right, go ahead and move on. Try the practice.